All right, I'm going to give you a little bit of help here on the assignment 6, which a few people struggled with, but really in reality, this isn't that terribly hard. The first thing is you just need to recognize that there are 15 truss members in this example, and 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes. These 3 external forces and an external positive force at A and an external positive force at J. Now, the A and J forces are relatively easy to find because you can just do it by taking the moment around A and the moment around J. What I mean by the moment around J is 2,000 times 1 plus 3,000 times 2 plus 5,000 times 3 plus whatever this is times 4 in the opposite direction is going to give you 0 because it's not rotating. So if you do that, you're going to find that this component force at J is 5750, and you can do the same thing around J and find that this is 4250. Okay, that's not really that hard to do. Now, let's look a little bit about how, with those external forces, how can we find all the forces in every member of this truss? It looks hard, but in reality, it is not hard. So let's first go over here. I'm going to make, this is one that I can draw on. Okay, so we're going to draw on it and make it so it's simple. Now, there's an external component force here, but I'm not worried about that external force. That's going to be a separate vector. All the external forces are in a separate vector. What I'm really going to do is I'm going to assume that everything is in compression. If everything is in compression, then all the forces are going to go from the center out. I have another video that says the exact same thing, but the center out. So component forces of each of these members is going to be along those lines. Now, if you're looking at forces in the x direction, there's really 2 of them. There's AC, okay, that's that force of this member on A. Well, the easiest way for me to do this is to set up a spreadsheet to help me keep track of these forces. So AB, AC, BC, BD, those are all the members. I put that along the top. Then I have the A and the X, the A and the Y, C and the X, C and the Y. I just put all the ones I'm going to solve for over here on the left-hand side. So if I want to solve for A in the X direction, I can look at this and say, well, the AC component member is this component right here, and it's in compression, so it's going in the negative direction, and it's -1. That's simple, because there's no angle. Okay, well, that's simple enough. Then I've also got this AB here, that component, and if you're looking at the component of, see this vector right here, you've got the Y component, which is this guy right here, that's the Y component, and you've got the X component of it, which is this guy right here. Well, the X component of this is going to be the actual force times the cosine of this angle, which is 60, or in this case, that's going to be it's going to be, let's see, it's going to be negative because it's going in the negative direction. So let's put it in there, -0.5. Boom. So and you can check that, but the cosine of 60 is going to be, and actually you can do this, go cosine, Google cosine 60 degrees, and it's going to tell you it's 0.5. So that 0.5 in the negative direction of the AC. And so what I do is I put it under the AC. Whoops, let's see. I'm sorry, the AB, because it was actually the component AB in the X, -0.5. Now let's look at it in the Y. So what forces do we have at A in the Y direction? We have the external force, which is in a separate vector, and then we have this component of AB in the Y. Well, this angle is 30. This is a 30-degree angle right there. So the cosine of 30 would be, which is 0.866, it's not hard to do, would be that component of that vector right there, and it's in the negative, and that one's going in the negative direction. So negative 0.866, and there's no other forces. So everything else along this line here is 0. So I can go booyah, the rest are zeros, and booyah, the rest of these are zeros. So not hard to do. And there I've now solved for AX and AY. Now, actually, at that stage, I could start solving for everything because this one is relatively easy. Negative 0.866 times 42 times AB is equal to 4250. I can solve that directly, and then I can actually turn around and solve for AC because that's only got one of them here too. So I could actually start solving these directly. Okay, I mean, if you wanted to, I can come over here and say 4250 divided by 0.866 is 4905. So the component AB is 4905. That is actually the force, the compression force in AB. And if I know that, I can figure out the component force in AC, which will literally be half of that. Wow, that's really not that hard to do. But we'd like to solve for all of these. So what do? Well, you just go on to the next one. I could go to B. In this case, I have here's my ones. I've got the AB, BC, and BD. Now, if you looked at, let's say, the X direction, the X forces, you've got negative BD. That makes this one easy. Let's see, that is B. So let's go to B. Oh, I didn't even solve for B and the X. I solved for B and the Y. So let's go down here and well, you know what? I could just add. I can make C of X B of X. I can actually change this around. All I need is 15 equations and 15 unknowns. So let's just say we're going to do B of X. Well, B of X, so I've got -1 for BD. And I have got two other forces. I've got AB, and that's going to be times the cosine of 30, and that's in the positive direction. So AB is going to be 0.866. And I've got BD, sorry, not BD, BC, which is in the negative, which is also going to be 0.866. So BC be negative 0.866, and nothing else contributes, so I fill in the rest of the matrix with zeros. It really is that simple. Now, I didn't do B and the Y. Well, I got B and the Y down here. It, by the way, doesn't matter where you put it, but your external forces over here on the side better be in the right location based on what you do here. Start filling them all in. I mean, I'll do B of Y for you if you want me to. B of Y. I'm sure everybody wants me to do that. There's only two of them here. They're both pointing up. Let's see, B of Y, and they both look like they're at, BC, by the way. See how quick, easy it is to make a mistake? Look at BC there. The X component vector there was actually cosine 60, not cosine 30. So that would have been an easy mistake to make. Those are actually 0.5. That's how easy it is to make a mistake. The directions were correct, but the bearings were right. So the component X of this is actually cosine of 60, okay, 0.5. This same one here, this is the angle here, cosine of 60, 0.5. Now, AB and BC are both at B. That's it. There's two component forces, both going up and both going in at 30 degrees, because I have to split this angle to get the cosine, or I could just take the sine. Sine would do the same thing, but it's still going to be 0.866. So that's the component of each of these is 0.866. So AB for B of Y, there's B of Y. AB was positive 0.866, and BC was also positive 0.866. And everything else is 0. There are no other Y component forces at B. Just work your way through it. That's it. You got to see why. You got to be meticulous. See how I easily made a mistake here about the 60. It is really easy to do that. We're going, oh, wait, shoot, that angle's 60, not 30. Or the 0.5 or the 0.866. It should, by the way, make a sense that the tighter the angle, the higher the number. Because if the angle is 0, the component force is 1. And of course, if the angle is 90, the component of force is 0 in that direction. All right, that's it. Work your way through it. Rest these are 0, and you might as well, when you come out here to B of y, you know that there's 0. There's no external force at B of y, so then this force vector over here is 0. You probably won't need that. I mean, you'll need this for the solution because you have to do the multiplication for the, but you basically need to make a matrix. This is going to be 15 equations and 15 unknowns, and you solve for it using Python. That's it. You got it. You can do this.